Hello, in this video we're going to look at the topic of momentum. So for question 1, the momentum of the snowball increases because two factors increase as it rolls down the hill. What do you think the two factors are? So as it rolls down the hill it picks up more snow, so its mass will increase. And equally, because it's rolling downhill it's probably getting faster, so its velocity increase. So momentum, two factors that increase it would be mass and velocity. So question 2, momentum can be calculated using an equation. So given that momentum is affected by mass and velocity, the equation for momentum is mass multiplied by velocity. So on to question 3, the units of momentum. So momentum, mass times velocity. Mass is generally in kilograms, velocity in meters per second. So because mass and velocity are multiplied together, the units for momentum are kilograms, meter per second. For question 4, if we're going to calculate momentum, well, we know the mass, we know the velocity, so we need to do mass multiplied by velocity, so that's 0.3 multiplied by 7, which is then equal to 2.1, and then the units, kilogram meters per second. For question 5, calculate the momentum if mass equals 5 kilograms, velocity is 12. So like before, momentum equals mass times velocity, so that's 5 times 12, which then gives the answer of 60 kilogram meters per second. Question 6 is the same skill to find momentum again, mass times velocity, 15 times 6, which is then 90 kilogram meters per second. On to the next one, calculate momentum if m equals 1.5, velocity equals 16, so that's going to be 1.5 times 16, which is then 24 kilogram meters per second. Question 8, slightly different, still finding momentum, but we need to be careful because of units. So it's always worth checking. So in this case, it's 400 grams. So straight away, that needs to be converted into kilograms. So you divide by 1,000. So that's 0.4 multiplied by 7. So doing that in a calculator gives 2.8 kilogram meters per second. On to question 9. Again, be careful with units. Mass is in grams. Still momentum, so mass times velocity. But we need 150 grams in kilograms, so that's 0.15. I've divided by 1,000. And then multiply that by 16, which then gives us 2.4 kilogram meters per second. On to question 10, the last one on this page. This time we've got two conversions needed. Mass, 158 grams, so that's then 0.158 kilograms. I've divided by 1,000. And for velocity, it's half a kilometre per second. Half a kilometre is 500 metres, so I've then multiplied by 1,000. So velocity, half a kilometre per second, or 500 metres per second. And like before, we're finding momentum, so mass times velocity, 0.158 multiplied by 500, and that then equals 79 kilogram metre per second. On to the next page, question 11 onwards, slightly harder, but still very much doable. So this time, we need to calculate the velocity. We're given the momentum. Momentum is given the symbol P, so P equals 1.5, and then the mass, 0.3. So if we get into good habits, momentum equals mass times velocity. Underneath momentum, we can write 1.5. Underneath mass, 0.3. And underneath V, we can write V. And now we can rearrange. So then we get V equals 1.5 divided by 0.3, which then equals a velocity of 5 meters per second. On to then question 2. So rather than writing momentum equals mass times velocity, I've done P equals m times V. Underneath P, 17, because that's 17 for momentum. Underneath m, 8.5, want to find V, so we need to rearrange. 17 divided by 8.5 gives a velocity of then 2 meters per second. On to question 13, again, P equals m times V, and I'm going to write underneath what the values are. But this time I need to be careful because it's 200 grams. So that's 0.2 or 0.200. So of course I've divided by 1,000. So P equals 1.5. So that's then divided by 0.2 for velocity, which then gives an answer of 7.5 meters per second. On to question 14. Again, P equals m times V. I'm going to write the numbers underneath. So 1400 equals mass times 20. We need to rearrange to find the mass. So that's then 1,400 divided by 20, which gives a mass of 70 kilograms. On to question 15, calculate the mass again. So P equals m times v, momentum equals mass times velocity. Momentum is 1.6, mass, we don't know, so leave it as m, and the velocity is 10. So we need to rearrange for mass, so that's momentum divided by velocity, 1.6 divided by 10, which then gives a mass of 0.16 kilograms. On to question 16. This time, find the momentum, similar to the first page, but with words in the question. So momentum is 0.5 because it's 500 grams, so divided by 1,000, multiplied by the velocity of 10, which gives a momentum of 5 kilogram meters per second. 17, find the momentum again, so P equals m times v. The mass, 400 grams, need to convert, so that's 0.4 kilograms, multiply that by the speed of 3, and that then works out at 1.2 kilogram meters per second. On to question 18, this time we're finding the mass. So momentum, mass times velocity, momentum 520, the mass we don't know, and the velocity is 8. So rearrange, we need a number multiplied by 8 equals 520, so 520 divided by 8 gives a mass of 65 kilograms. On to question 19, momentum is 50, the mass of the ball 500 grams, so again divide by 1,000, so 0.5 kilograms. So 50 equals 0.5 times v, so need to rearrange, v equals 50 divided by 0.5, so the velocity is then 100 meters per second. And then number 20, we've got a large momentum this time, 700 million kilogram meter per second, and quite a large speed, 1,400. Same equation though, P equals m times v. Then being careful with the number of zeros that we've drawn, so 700 million equals mass times 1,400, and then again being careful when we put it into our calculator that we put the right number of zeros in, so 700 million divided by 1,400 gives a mass of 500,000 kilograms. Hope you found that useful, and don't forget to press the subscribe button to get notified for any future videos that are made. Bye bye.